Okay, so let's go over the brick wall problem that was in the CodePath course portal that we had to do today. Okay, so in case you haven't read it before, you have an array that represents a brick wall. And what you're trying to do is cross the minimum amount of bricks. So as you can see here in this little spot here, when two bricks line up together, there's a spot that you can run through. And if you have something like this where they all line up together, you don't cross through any bricks. But because there are different bricks at different places, the likelihood that you're going to cross through a brick is pretty high. So what you want to do is find where you can cross the minimum amount of bricks and then return that number. So how do you do this? I think the best way to think about this problem is to visualize it. So what we did, we actually kind of just blew through the umpire thing because this problem was really hard for us to understand. So what we did was like, we looked through this test case and we're like, okay, how do we know that this has the minimum amount? Like, how do we know that the minimum amount of bricks that we can pass through is 2? And what we found was, when we thought about it for a while, we realized the spot that has the maximum number where bricks line up side to side, that spot will give you where the maximum, or that spot will give you where the minimum bricks to be crossed is. I'm not really great at verbal communication, so I think the best way to do this is to show you a whiteboard. Okay, so let's say that we have this here. We've got 2, 4, 6, we've got 12, and we've got 1, 4, 7. So we know a couple of things. We know that each width is going to have the same sum here. So the sum here is going to be 12, the sum here is 12, and the sum here is 12. We also know that if there is no breaks here, then that's like, you have to cross through, like that's just it. Also, we know that when there is a comma, like another index, we know that represents a gap. So there's a brick here and there's a brick here. So we know there's a gap right there. Oops. We know there's a gap right here. We know there's a gap right here. Same with this, same with this. So how can we figure out the, like, where the maximum, like, how do we know where the maximum amount is? And so what we thought was, kind of like if you've done the rod cutting problem before in 325, we thought, okay, so what if you have like one row and it's just all brick, right? Basically, and it's like the length, the length here. So we have like a length equals 12. So basically what we know is, like, here, we know that at length equals 2, there's a gap here. So let's do 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's going to be, oops, I think that's wrong. Okay, sorry, I just can't count, apparently. Okay, so we know at x equals 2, there's a gap. So we're going to go ahead, 0, 1, 2. This is length of 0, this is length of 1, this is length of 2. We know that in this hypothetical brick of length 12, there's a gap at 2. And then we also know at this 4 mark, there's a gap, but it's not at length equals 4 because there's a 2 right here. It's actually at length of 6, there's a gap. So 0, 1, 2, 3, 4, 5, 6. So there's a gap right here. 12, there's no gaps because we know that there's no additional element. So we know there's no gaps. Here, we know there's a gap here because there's another element here. So at x equals 1, there's a gap. we know there's another element here. So at x equals 1 plus 4, which is 5, we know there's a gap. So we're going to count this. So remember when I said that the maximum places where it lines up, that's going to represent the minimum bricks that we need to cross. Okay, so we're going to get the maximum of this, which is 1. And we're going to subtract that from the number of rows, which is 3. Rows minus max gaps. And that's going to give us the minimum amount of bricks that need to be crossed, which equals 2. And that makes sense, right? Because there's a gap here and we're going to cross 12 no matter what, but it doesn't line up. So we're going to cross 2. There's a gap here. We're going to cross 12 no matter what, but it doesn't line up because this is at 5. There's a gap at x equals 5. There's only a gap at x equals 6. So we know we're going to cross 2 bricks. And it's the same thing here as well. There's a gap at 1, but there's no gap at 2. So we're going to cross 2 bricks. There's a gap at 5, but there's no gap at 5 here. There's a gap at 6. So we're going to cross 2 bricks. And that's our algorithm. And let's actually do this all over again. And I'm going to show you another test case, the first test case that we actually went through. And we're just going to have, so we're going to keep this. And we're going to have 2, 4, 6. And so what we're going to do now is actually pretend that we're like, I don't know, the compiler or whatever, and we're going to iterate through this. Okay, so we have 2 here. Is there another element? Yes, there is. Okay, so, and let's actually take the sum. So we're going to start for each row, we're going to keep track of the sum. We're also going to keep track, I'll show you that later. Okay, so we're going to keep track of the sum. So now we're at 2. This is where we are, and this is the next one. We're at 2, and we're going to change the sum to 2. Okay, is there another element? There is. There's 4. Okay, so go ahead and at sum of 2, we're going to keep track of the index. Put a 1, 0, 1, 2. I'm actually going to make that a different color. Okay, so now let's keep going. Is there another element? Yep. Okay, so at, oops, this is 6. So at sum equals 6, make a 1, or just track it. Okay. Is there another element? No. Okay, let's keep going. Is there another element? No, that means there's no breaks. Let's keep going. Let's change the sum back to 0. Is there another element? Yes. Okay, so that means there's a break at sum equals 2. So 0, 1, 2. Now we're going to bump this number up to 2. Okay, let's keep going through the columns. Is there a next element? Yep. Okay. So now we're going to bump up the count at x equals 6. So now that's 2. Okay, now we're going to take the max number of breaks, which is 2, and we're going to subtract that from the rows. So rows minus max. Whoops. So rows minus max gaps equals min cross. So rows, which is 3, minus max gaps, which is 2, equals 1. So the maximum amount of bricks that we need to cross is actually 1. And we can see that either way. We can go here, whoops, because these two line up. So we can go here, we only cross 12, or we can go here and we only cross 12. And that's pretty much what our algorithm is. Then something that Charlie put in out, actually, we don't actually have to store something here for every single slot. We can only just keep this is an array right here. We can only just keep track of the spots that do have gaps. So instead of doing an array, we'll just have a dictionary. So we'll call it gaps. And if we are, as we're iterating through, if we find a gap, then we just keep track of the location. So, or we keep track of the current sum. So we'll say the current sum at, like, say it's 1, and then we also found 1 at 6. So as we're iterating through this third row here, and we approach 2, and we know that there's a gap, we just say, okay, let's bump it up. So now it's 2. We're at 6. Is there a gap? Yep. Is it already present? Yep. So our previous 1 now is a 2. And one thing that we can do, because iterating through the hash map and figuring out what the max value is, that would be O of n. So instead of doing that, what we're going to do is we're going to keep outside of this dictionary max gaps. And so let's say we're still here, and our max gaps after row number 1, our max gaps equals 1. Okay, if we're adding this and we see that it's bigger than the current, what the max gaps is, then we change that. And then when we return at the end of our algorithm, what we're going to return is rows minus max gaps. And that is going to represent the minimum amount of bricks that need to be crossed. So hopefully that makes sense. That's it. That's all I got. Enjoy.